Hello everyone. Today in this session I will be covering the topic of permutation algorithm. So the question is we have the given input a string, let's say the ABC, and we need to print out all the possible outputs permutation of that three characters A, B, and C. So the output would be ABC, ACB, BAC, BCA, CBA, and CAB. So this is the combination of all these three characters. So as we know in the permutation logic, first place can be chosen. Mm, there is the three ways we can choose the character in the first place. So that is the three, so something like that. So first place can be chosen in three many times, then second place we will have the two, and third place we will have the one. So the altogether combination is six combinations we get from the three characters. So before writing code, let's move on the some theoretical concept and how we will crack this problem by coding in the Swift. So here is the brief diagram. I will explain the how we will crack this question. So the see, we have the number of characters three, and the in this case we will have the depth of the tree is three, and number of combination will be the 3 factorial. Whatever number of characters we have, the combination will be the factorial of that number. So the we'll get ultimately the six combination of this permutation combination of this string. So let's start to the theoretical part or the algorithmic part for this problem. So at the we have the three characters A, B, C. So the in the next level of the tree, we will fix the first position of the string, that is the first character of a string. So first character of a string. So um, we have the zero index. uh, think like a programmatically we need to fix the character at the zero index. So A is swapped with A, so this will be ABC. Now A will be first position will be chosen as the A can be swapped with B. A can be swapped with B. So if A is swapped with B, then BAC. Now A can be swapped with C, that is the CBA. So simply we are swapping the character with itself with one index character and the two index character. So A is being swapped with itself, then we have the result here, and A is being swapped with another character, then we have the another result here, and again A is swapped with another character, then we have this result. See, in the next level of the tree, what we did is we have fixed the first character. So in this section we have fixed A, and the now we have the sub problem is B and C. Among these we will try all the combinations. Similarly, in this route we have fixed the first character as a B, and the rest of the sub problem is the A and C. Similarly, in this child, we have fixed the C as a first character and rest of the character B and A. Now, um, as I have explained that the first character can be chosen by three ways. So we have the three child here. So this one now let's move on this route. Now we have already fixed A. Now we need to fix the second character. So the second character can be chosen two ways. So the it can be swapped with itself, B can be swapped with itself, and B can be swapped with C. So when I swap B with B, then we have the ABC, and when I swap B with C, then we have the ACB. So the possible options are these two. So in this the node, we have fixed the first character and second character, and the now remaining character is C. So there is no need to move further because that is the last one character. So we need to stop here. Similarly, we did the same flow here. A is swapped with A is swapped with C, and for this node, B is swapped with B, and B is swapped with A. So the altogether we got the result here. See, ABC, ACB, BAC, BCA, CBA, and CAB. These are the possible options of the permutations of the given ABC. So the technically we are swapping the character with itself and the remaining characters, and we are moving till to the next level of the tree until and unless we complete the swapping process for the all the characters in the no, first level of this tree. We fixed the first character, and in the second level of this tree we fixed the second character. Similarly, we can continue since we have the three character string, so we can go up to the depth of the tree is 3 only. So this will gives us the solution of the permutation. So the technically there is only the swapping mechanism and it solves the problem. So let's try to write the code for this, and I will be explaining the how it works side by side with reference to this image. So let me write code first. So first of all, let me open this image also. Okay, so let me make a permutation function. Func permutation, and I will take input as a string, and see during the when we choose the character, it should start with the 0 index, no? So the marker should be for the first character, and in this second level of tree, marker should be for the second character, and so on. So we have the index also for left, let me say left index, and int. Now if let me make more space here, sorry. Okay, let me write the code first, then I will explain. So if left index equal to input dot count -1, then we have traversed all the string, then I should print input and return. Okay, otherwise I need to move on the swapping process for all the characters. So for I in left index up to, let me copy this one. Okay, left index. Okay, so see, let's try to map with this image, this gram tree. So when we fix all the characters, suppose we start for the first index of a string 0 index, then the for the second index one index, and for the last one index last character, for the last character. When we reach up to this, then this is the condition. So we have fixed the character for all these positions. At that time we should print the string. So this condition, if condition, comes only when we reach at this point, because we have fixed all the characters for every positions: first position, second positions, third positions, fourth position, so on. So this is the condition which will be met when we reach here. Now otherwise we need to make all these possible options. So for that I'm going to write the loop. So the first of all, what should I do? uh, I need to first fix character at index I. Suppose I is 0. Suppose if I have started from here, I is 0, then I need to fix the character at the 0 index, no? So the at this point, so I need to swap, swap like I have shown in this tree diagram. So swap with, how to swap? Where swapped a string, I need to make a one swap function also. So the basically if I is 0, then 0th index will be swapped with 0 index, 0th index will be swapped with first index, and 0th index will be swapped with uh, second index, and so on. So this is the for loop, this one. So let me write the swap function first. Swap input string from int to int. Now add characters, character array is input string. Now character array dot swap at index from to 2. Okay, this will swap and give me the array, and I need to convert it in the string form. Okay, return string character array. Okay, so now I'm going to swap. So input will be input string, and from will be left index. So the first time left index will be 0, and left index and 2 will be I. Now once I will swap, then I will move on this point. This point we have created the another sub problem. So the sub problem, that is the B and C. Again we need to apply the recursive algorithm for B and C. So at this point I am going to call the permutations function recursively. Permutation. So see, we have completed for first 0 index. Then let me pass swapped string. So whatever the string will be swapped, this will be passed for the further processing, not a original string. You should remember that one. So whatever string we received here, that should be passed for the further permutation. So the swapped string, and the left index should be incremented by 1. So the left index should be left index plus 1. This means This means we have completed up to this. Now for the further permutation recursive call, we need to, we have the sub problem B and C. So we should not, we have to increase the left index by 1, so that it will mark to the first index of this string, because the is yeah, first index, zeroth, no, second index of this string. So okay, now what is it saying? Okay, now, so this is the process for, we can say, sub problem. Okay, now we have the backtrack. I will explain this later. Backtrack. So in this case we will swap again the, and we will get the original string. Okay, why it is showing me error? Ah, it should return a string. Okay, now it's fine. So now let's check whether it works or not. So let input equal to ABC, permutation input, input, and left index should start from 0. Let's see. Okay, see, we got the permutations of the string. So now let's try to recap how it is working. So first of all, we have started to fix the string for the zero index during the first call. So which will be marked at this point, uh, at this point. Now permutation method is called. Now this if will be false, so this will be executed. This will open the three nodes, three nodes, first node, second node, third node. So see, left index is 0, so 0 will be swapped with 0, this one, so we'll get this one. 0 will be again swapped with 1, 1, so we'll get this one, and again 0 will be swapped with 2, so this one. These three nodes we will got here. See, so these are the things. Now once we will get these three nodes, the next task will be, we need to call the subproblem. Subproblem means we have fixed the character for the first index, that is the 0th index in case of the array. So we need to call the permutations again for by incrementing the index by 1, so that this is the subproblem. So the B or C, BC, AC, and CBA, this will call the permutation again. Now the thing is the why I am doing this one. So see, once we will reach here, then we need to go up at this position. So at this position again we need to get the original strings, because we have the ABC string and we cannot process this string to get the another permutation of the string, that is the ACB. So we need to reverse here. So again whatever we have swapped previously, we need to correct that one. So backtracking is used, that's why. So we have corrected that that swapped a string. So we'll go in this node again, and again we'll advance for the another permutation of the string. So this is how it is working. So basically there are the three components. First of all, we need to swap the string with with that character, same characters and the remaining characters. So a with a with b, a with c, like that. And then we call the permutation, that is the sub problem, a recursive call. And by incrementing the left index, so you should not forget to increment the left index, because that will point to the sub problems mm, first index. So mm, so you should do that one, and then after you need to implement the backtrack, and this is how it works. So now let's think about the time complexity. So we have the how many depth of the tree is 3, yeah, 3. So that is equal to the number of the characters. If number of characters is 3, then 3. So the let's denote the number of character as n. Then the n will be the depth of the tree, and the number of permutations for these characters is n factorial. So the computational complexity of this approach is n asterisk n multiplied by n factorial. Big notation of that. So this is how the permutation algorithm works, and you can get the permutation of the given string. So that's it for today, for this video. Happy coding. Thank you.